Binding energy is the energy that an atom has that holds it together. Okay, because the particles in the nucleus don't want to stay together. You've got protons that repel each other, so we can think of them being bound together by an energy. In this case, we want to calculate the binding energy for one iron 56 atom. So our atom is iron. It is 56. We only have one equation in nuclear, and that's E equals mc squared. Now, it all comes down to what we plug in for the mass. So if we want binding energy, what we need to think of in terms of this mass is the mass when the particles are unbound, when they're not in the form of an atom, compared to the mass when they are bound together in the atom. So then this mass is going to be the mass of the individual particles that make up the nucleus minus the mass of the atom when it is one unit and it is combined, and then multiplied by c squared. Now, we're going to have to get some numbers from the periodic table, and specifically this is the isotope table. So I have the isotope table pulled up. You have a link to this on the problem sets. So we want iron, so I'm going to click on iron, and specifically we want iron 56. So we are on iron 56. This tells you how many protons and neutrons you have, and it also tells you the mass of the atom. So then I'm going to make a few notes, and then I'm going to move the periodic table out of the way. So then we have in our particles 26 protons and 30 neutrons. And then the atom is 55.934937.475 atomic mass units. Now, moving our periodic table out of the way, I wrote our specific values down there, 26 protons, 30 neutrons, and then the atomic mass. Now, our protons and our neutrons, you also have a constants table on the problem set that gives you the atomic mass of the protons and the neutrons. So let me fill those in. So then I've got 26, the mass of a proton, 1.007276 atomic mass units, and then 30, the mass of a neutron, 1.008665 atomic mass units, minus, I'm going to write this one more time, 55.93497475 atomic mass units. Now, this mass of particles will not agree with the mass of the atom. You're always going to have more mass when you have the individual particles, because some of this mass then, when it's an atom, is not expressed as mass, it's expressed as energy. Taking this difference gives us the mass defect, and then we're going to have to convert that into atomic or into kilograms to get our mass in joules. So this difference will convert one atomic mass unit is 1.66 times 10 to the negative 27th kilograms, and then all of that is multiplied by the speed of light squared, 3 times 10 to the 8th meters per second, quantity squared. So when you crunch that entire calculation, we're going to get a binding energy of 7.68 times 10 to the negative 11th joules. And again, this is binding energy because there are multiple different kinds of energy we will calculate in this chapter. And the difference, same equation, the difference really comes for what you plug into the mass. For binding energy, it is particles minus the mass of the atom. Ponder physics.